All right, so most of the action with adding and subtracting fractions is probably going to happen when we don't have a common denominator, and that's the focus of section 4.5. What this is going to amount to is if we don't have a common denominator, trying to find one, right? We just can't add if we don't have one, so we need one. This leads us first, before we can actually deal with any fractions, to the LCM slash the sort of LCD. So this stands for the least common multiple slash denominator. So, right, LCM or LCD. I'm kind of grouping these two things together. The LCD, the least common denominator, just is the least common multiple, but in the context of fractions, right? In the context of having denominators and fractions. So sort of definitionally, right, what this means, right, is it's the smallest number that both of your sort of given values divide into evenly. So this is kind of related and sort of a similar concept to the GCF, right? The greatest common factor. Obviously, the language is different, and sort of being the greatest versus the least is extremely different. The big thing here to just sort of keep in mind is a factor, right? Is a number that is smaller than your given number, right? Your value breaks into factors, right? 3 and 4 are factors of 12. And then a multiple is a bigger value than your number, right? A multiple is a number that your sort of value divides into, right? That you're sort of dividing. 12 times 2 is 24, so 24 is a multiple of 12. 36, 48, yada, 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 right? Things like this. So what I want to go over is just sort of finding a least common multiple. We need to sort of identify this before we can do anything else. And there's really two kind of strategies. Let's sort of pick some example numbers here to work with. Let's do something like, so let's find the LCM for 9 and 12, just for example. And so we're going to do this two different ways. Strategy number one. So this is more of a brute force kind of technique, meaning you just sort of do everything as directly as possible. And so this is going to be simply list the multiples and ID the smallest common value. So like, how am I supposed to find the least common multiple? Well, for example, find all of the multiples. Not all the multiples, right? Because of course they go on and on and on and on and on. But make a list of multiples, however many sort of long, and then just like look at the list and see where the first one is that shows up in both of them. So let me sort of run us through this, right? So what are my multiples for 9? Well, 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. Times 6 is 54. Times 7, 63. We're just running out of frame a little bit there. Let's sort of hope we can have a little overlap by there. The catch here is you're always going to get a common multiple, because at the very least you could just do directly 9 times 12, right? So obviously 9 times 12 is going to be divisible by 9, and 9 times 12 is going to be divisible by 12. In general, though, if there's any kind of overlapping factors between your two numbers, you'll hit on something smaller than that. So 9 times 12 for us would be something like, what, 108? So I know 108 is there. The hope is we can sort of come up with something that's smaller than that. So let's see. So our multiples for 9. So 8, 27, 36, 45, 54, 63. We could keep going if we need to. For 12, so what do we got? Well, times 2 is 24, times 3 is 36, 4 is 48, right? Times 5 is 60, 72. And let's actually pause there, because I spy with my mathematician's eye, 36 showing up in both columns, and that's the earliest instance of having any sort of overlap here. We could kind of say if we kept going, for example, with the 9s, we would have a 72 coming up next, and that would also show up here in the 12s. So once we hit one, we're going to hit more than one. The idea here is we're looking for the least common multiple, and so that's going to be the smallest of these values. So for us, that's 12 times 3, or it's 9 times 4. What's happening here is that 9 and 12 both have some overlap together, and we're actually going to sort of look at that a little bit more closely when we look at strategy number 2. And so how much overlap there is between your two numbers, as far as what the overlapping factors are, how many are there, helps determine sort of how big or small your LCM is going to be. So the more overlap you have, then in theory, the sort of smaller your LCM is going to be. Strategy number 2. So use the GCF, and what you're going to do is you're going to build an LCM. And so what it's going to be is your two values, so A times B, and it's going to be those values divided by the GCF, right? So this is where sort of values are A and B, right? The numbers that we're sort of starting with are A and B. So there is a formula here that we can sort of get an LCM from. So the LCM would just sort of be the product of the two numbers and then just divide by the GCF. The GCF itself, right, is how much overlap there is between the two numbers. So what's happening here, right, is you're sort of taking the product of the two numbers and then you divide away the overlap. And that kind of gets us directly to the GCF. Let's do, as an example, this same numbers, right? So let's sort of do this version for 9 and 12 again. So what this means is we're going to sort of do the same thing that we did a minute ago, which is find the GCF a minute ago, right, a couple sections ago. So for 9, this would be 3 and 3. 12 would be 3 times 4, which would be 2 and 2. A student showed me one thing can be useful here at the end of each of your branches. If you sort of mark a little line over it, it helps to sort of identify the ends of all the branches. So the GCF for us here, right, is going to be equal to all of these overlapping things. Pardon these dings. I have to leave my texting and everything on, because if I don't, it turns out the video won't record sound, as we found out back in section 3.4. So don't mind all these text messages coming in. My cousin is losing to me in fantasy football, so that's what's happening. In any event, where is the overlap here? Well, the overlapping values, right, would be sort of 3 and 3. So my GCF is going to be made of 3. And that's it. And that's the end, right? Because, you know, there's another 3 here, but it doesn't sync up with either of the other values for 12. So my GCF for 9 and 12 would be 3. And so what that means for my LCM is, so it's going to be 9 times 12 divided by this value 3. So what I would do is not actually do this multiplication. We said this is going to be 108, but who wants to deal with 108 if they don't have to, right? Just divide this out of here kind of right away, and we sort of know by definition this is going to divide into these numbers. So if we divide, right, 3 into the 12, it would leave us with 4, and we get the LCM we were expecting, 9 times 4, which is 36, right? So finding a least common multiple, you can do either of these strategies, right? Either of these things work. I would like to do one more example. I want to throw a couple variables in here just because that's kind of interesting, and so why not see that? Fresh page. So let's do LCM/LCD with a few variables. So what's going to be happening here is we're going to do the same kind of strategy, the same kind of steps that we were just doing, but we need to sort of also be mindful of any variables, right? A's, B's, C's, X's, Y's, and Z's, and all the rest. So let's do, for example, so find LCM for, what should we do? How about 10a squared, and let's do something like maybe 8 times b. And so what I'm going to suggest here is, well, gosh, maybe let's build it up with the variables. Maybe that's easier. So let's kind of use strategy number 2. We'll do some more of these, of course, in the other thing, but I can kind of break these apart. I don't know that we've actually really done this yet, but you can sort of break values up into factor trees, even if they have variables involved, right? So, for example, something like 10a squared, you could just split into 10 and a squared, and then a squared you can just break into a times a, and then 10 is 2 and 5. 8b, right, you can kind of sort of break into 8 and b. This would be sort of 2 and 4, and then 4 is going to be sort of 2 times 2, right? So the ends of all of these things would be sort of here, here, and here. Well, what does this mean? A couple things. One, our GCF. Right, where's the overlap? It's actually not a ton of stuff here relative to all the different things we're working with. I guess it's just this 2, sort of lonely 2. You know, 10a squared has 10, and then it has a and a. 8b has more 2's, which don't sync up, and then it has a b variable, which is obviously a different letter than a. So those guys aren't in sync. What this means for us, that as far as building our LCM, so it's going to be equal to 10a squared times 8b divide by 2. And so we can kind of break this down, I guess, in either position. We could say, you know, 2 into 10 or 2 into 8. I'll just do 2 into 10, I suppose, because it's right there. Would leave us with 5. So my LCM here, right, kind of 5a squared times 8b. So this is going to be 40 with a squared and with the b together, right? So if I had a fraction that had, you know, these numbers and these variables involved, I'd have to not just sync up the numbers. 8 and 10 would sort of sync up at 40. I'd also have to sync up these variables. And so what I would need to sort of take in particular special note of is that this would be, right, 40a squared. So this would be like 10a squared times, what are we missing? Well, 4b, right? Or you could say that it would be our other version, 8b times what? Well, 5a squared over here. You don't necessarily know why that's so important just yet, but trust me, in the next video, when we do this in a fraction context, knowing how to get to the least common multiple from sort of either of these values is extremely important. That's going to help us sort of rewrite and scale up our fractions. But that's coming up next in 4.5 part 2.